Okie dokie. So, finding unknown sides. So, we're going to use the trig ratios that we learnt in the previous lesson to be able to find unknown angles and sides. So, if theta is in degrees, so that is, we've got one of these angles, like, so here, here, or here, okay? So, if we've got one of those, what we can do is we can, just give me a sec to change my razor to stroke. Yeah, okay. So what we can do is we can actually find what one of the missing sides are. So for example, I can find what this length is, only knowing, so this and this. So before, when we were doing Pythagoras, if I wanted to find what this length here was, I needed two sides to find the third side. With trig, we can actually, use the just one side and one angle to be able to find what a missing side is, okay? So we're going to be using the sine ratio to cosine ratio to tangent ratio based on what we've been given, okay? Now, angles that are not whole numbers are sometimes expressed in degrees, minutes, and seconds. So for example, 22.5 degrees can be written as 20 degrees and 30 minutes. So minutes being made up from 0 to 60 before it ticks over, just like minutes of the day or in a day, and seconds as well is the same as that. So 50.175 goes to 50 degrees, 10 minutes, and 30 seconds. And so as it says underneath, there are 30 minutes in 1 degree and 30 seconds in 1 minute. The calculator can be used to make this conversion, so you don't actually have to do it yourself. But with that being said, let's have a look at some examples. So we're starting with example 2. Decide if you would use sine, cosine, or tan to help find the values of x in these triangles. So pretty straightforward. All we're going to do is we're going to identify which one we're going to use by labeling our triangle to begin with, and then from there just picking which one is the one that's we're going to use. So we're always starting from the angle that we've been given. So in this case, we've been given that this angle down here is 38 degrees. So would I use sine, cos, or tan? Well, in this triangle, I've got an opposite, a hypotenuse, so I'm going to label that a hypotenuse. I've also got an opposite, which I'm going to label as such. So the ratio that uses hypotenuse and opposite, well, that's my sine ratio. So sine theta is the one that I'm going to use for that one. And that's all we need to do. So again, just like with this one, we've got an opposite and we've got an adjacent, okay, because there's no hypotenuse. So opposite and adjacent. So the one that uses opposite and adjacent is tan, okay? So I would use tan to work with this triangle. And finally, we've got this one here. We've got a hypotenuse that goes down like that. We've also got an adjacent because it's next to the 24 degrees. So the one I'm going to use is for that one is cos of theta. Now, use a calculator to evaluate the following to correct 2 decimal places. So what we're going to do is we are going to use our calculator ourselves, and we're going to use this calculator to find it. So what I've got is I've got my calculator here. It's maximum it can go, and nothing's working for me today. So here's our calculator. I've got the display, just a bigger display, okay, to see what's going on there. Okay, so sine of 50 degrees, all we're going to do is, hopefully you can see this, but there's a sign on our calculator just here. Hit that, put in 50 degrees, so the degrees button is that one. Close the bracket and hit equals, and we get 0.76. And it's to correct 2 decimal places, so it's going to be 0.77 in fact. Okay, and that's all you need to do for that one. Cos of 16 degrees, so we're going to put in cos 16. Now you don't have to put the degrees in, okay? So you can just hit that one and we get 0.96. So 0.96. Tan of 77. So tan, hit the tan button. 77. 4.33. Okay, next one is tan of 15.6 degrees. So we're going to go tan 15.6. Close it off. So when you do that in your calculator automatically picks it up as degrees. Okay, and the reason it does that, if you can see, there's a little d just here. Okay, then that d is giving you these answers. What I would ask you guys to do while we are doing this together is actually put these into your calculator too and check. Because sometimes you might not actually get those answers. So if I just quickly do if I just quickly change something in the settings, what happens when I put 10 or 15.6 in here now? What you'll notice is I'm actually going to get a different answer. Okay. And you'll notice, so looking up on the display, so there's a little R here. If you've got this little R, it just means your calculator's in the wrong setting. And to fix that, what we're going to do is, all you need to do is just hit Shift and then the mode and setup. And then what you will see is the 4 rads. We're going to hit that one. We're not going to hit that one, sorry. We're going to hit this one, the next to it, 3 deg, or 3 for degrees. And basically what that means is it puts your calculator into degree mode. Continuing on, we're going to go sine. Okay, now we've got 22 degrees and 30 minutes. So what we're going to do is we're going to start off by putting 22 degrees in. Okay, now to put 30 minutes in, what we're going to do is we're going to hit 30 and then hit that button again. Now it does display the degrees simple, but your calculator knows that if you've already got a degrees in before it, so like 22 degrees here, it will automatically register that one as minutes. And again, if you were to continue going and then put seconds in as well, you would just hit that button again and it would register the seconds too. So the last one is 0.38, okay? And that's all we need to do for question 3, so it's just some calculator work. Find the value of x in the equation cos 70 degrees is equal to x over 9, okay? So let's write it out. Cos of 70 degrees is equal to x over 9. Now, the idea behind this is we want to get the x by itself. Okay, and to do that, we need to get rid of this 9 that's sitting on the bottom. To get rid of the 9 on the bottom of the equation, well, what are we going to do? And I hope you came up with the answer. Multiply both sides by 9. Okay, so this becomes 9 cos of 70 degrees is equal to x. So what we're going to do is we're going to put that into our calculator to get an answer. So 9 times cos of 70. And that's equal to 3.08 to 2 decimal places, okay? So all we did was remove that 9 by multiplying by 9, and in fact I can use a different colored pen, so times by 9, and times by 9, and that's way too thin for me. Times by 9, times by 9, okay, and that gives us our answer there, so 9 times cos 70, okay, that's all we have to do, so just to rearrange that one. Now finally, we've got some triangles that we are going to solve for values, okay? So these were the ones that we had in question 2, example 2, but now what we're going to do is we're going to use some trigonometry to actually solve or find what those values of x are. So that is what's this value, what's this value, and what's this value, okay? So what we're going to do is we're going to start off by identifying which trig ratio we need to use. Now, it doesn't give us a hand this time by telling us what the ratios are. So what we're going to do is we're going to start off by writing SOHCAHTOA on the top of the page. This is just a little way to remind ourselves, okay, which sides go for which trigonometric ratio. So sine uses O and H, which is opposite and hypotenuse. Cos uses A and H, and tan uses O and A. So looking at this triangle down here, we've got the 38 degrees. We've got a hypotenuse, which is the 7. And we've got the opposite, which is x. Okay, so this is, well, not x, this is the opposite. Okay, so the trig ratio that uses opposite and hypotenuse is sine. So we're going to start out by writing that down. Sine theta is equal to opposite over hypotenuse, okay, or O over H. Okay, so sine theta is equal to O over H. So the theta is just the angle that we're using in this case, so which is 38 degrees. So we're going to be using that 38 degrees here. That's equal to the opposite. Well, we have no value at the moment, so we're just going to write x over the hypotenuse, in which case is 7. Now we've got a question that looks exactly like we did in question number 4. What we need to do is we need to get the x by itself by removing that pesky 7. And to do so, we're going to multiply both sides by 7. So we get 7 times sine 38 degrees is equal to x. So x is equal to, we grabbed our calculator out, we're going to go 7 times sine 38 degrees, and that's equal to 4.31. Correct, 2 decimal places. Okay, continuing that with the other two, here's my angle here. We've got the opposite in this case, and we've got the adjacent. Okay, opposite and adjacent. So opposite and adjacent, OA, we're using tan. So tan theta is equal to O on A. So remember, theta is the angle we're using in this case, so that's 42 degrees. The opposite, well, I don't know that yet. That's just x over the adjacent, which is 4. Okay. Now, my next step is to say, well, how do I get that x by itself? And to do so, we're going to multiply both sides by 4. So that leaves us with 4 times tan 42 degrees on the left, which is equal to x on the right. So my x value is equal to, and we're going to put that into our calculator, 4 times tan of 42. That's equal to 3.60, or just 3.6, but it's 2 decimal places, so we'll put 60. Last one, we've got a hypotenuse in this one, and we've got an adjacent, so just A for adjacent. And what uses hypotenuse and adjacent? Well, that's cosine. So cos of theta is equal to the adjacent, which is x, over the hypotenuse, which is 10. Oh, sorry. Ooh, we're not doing that just yet. We're writing down our ratio. So A over H. Now we're going to put in some information. So the angle we're using is 24 degrees. So we write cos of 24 degrees is equal to the adjacent. Well, that's just our x value over our hypotenuse, which is 10. Now to get rid of the 10 from the right-hand side of the equation, we're going to multiply both our sides by 10. Okay. And that leaves us with x on the right-hand side and 10 times cos 24 degrees. So x is equal to, and we're going to put that 10 times cos 24 into our calculator, and we get an answer of 9.14. Okay. So we're only doing questions 2 to 5 in this one. Okay. So questions 2 to 5. And that's pretty much it for this video. So we're just practicing those trig ratios, and I'll see you guys in the next one.